Hi guys, so today we'll be solving this problem called final prices with a special discount in a shop. In this problem, basically we've been given a prices array, which is having the price of ith item in a shop. So let's take the first example, 84623. Now there is a special discount for the items in the shop, and the algorithm for it is that it needs to satisfy two conditions. So first is that we need to select. So if this array, if we select an ith item, so let's say we select I as 0, so there are two conditions. One is that we need to find a j such that a j is greater than I, right? And we can have prices of j less than or equal to prices of I. So which means that in this case, 8, we need to find, first of all, the minimum index which is greater than I, which satisfies the condition of this, which is that it needs to be smaller than the prices of I value. So in this case, 8, right? So which is the smallest index which is after 8 and also has a value which is lesser than 8. So it is 4. So right now, the final answer would have something like 8 minus 4. That is a discount. So which is 4. So 8 minus 4, that's the discount that we have, which is 0th position is 8 and first position is 4. So the minimum index which is greater than I, which is 1, right? So 1 is greater than 0, and prices of j is less than equal to prices of I, which means that 4 is less than equal to 8, right? That's the condition which is being satisfied. So yeah, basically that is the problem that we need to solve. So one of the very simple solution would be that we just have two loops where we get the first value, and we actually iterate again the array after the ith position to get the smallest value and the minimum index to satisfy the discount condition. Now, there is another way. The time complexity for that would be, for the first approach is O of n square, because we will be, iterating through the array again with two loops. And space complexity would be O of n, as we are storing the result in an different array. So yeah, that would be the idea. Now, let's try to optimize this into O of n solution. So there is an approach which we can use, is that we can store the values which are ahead of I in a stack. So we'll use a stack to basically optimize this. Definitely the space complexity increases with this, but let's go ahead with the approach. Yeah, so let's take the first example, 8, 4, 6, 2, and 3. In this one, so what we'll do is we'll maintain a stack. And in this stack, I'll actually store the values or like, the indexes in this stack, and we'll be iterating. So let's see. So let's say we are on 8. So once we are on 8, we actually put the index of 8 inside the stack, and we go ahead. Now we're on 4. So on 4, we have, we need to check a few conditions. So one would be that is j greater than I, and prices of j is greater than less than equal to prices of I. So what I'll do is that I'll have another while loop inside the for loop, such that we need to keep on check, so that we keep checking about the values which are at the top of the stack. So in this case, so one condition was that prices of j is greater than equal to prices of I, right? So to do that, what I'll do is, currently I was here and then I was here. So I is at one position. So what I'll do is I'll see if 4 is smaller than the value which is at the top of the stack. So right now the index is 0. So value at index 0 is 8, right? So 8 is definitely greater than 4, which means that we can apply the discount on 8, right? So I'll have a result array such that what I'll do is we will right now we'll pop this out from the stack. So we'll have 8, and at the 8th position, so at the 8th position, what I'll do is I'll go ahead and actually decrease it by prices of I, which is 4, right? So it will be 4 here, right? And then I'll actually push the ith value inside the stack. So now we'll have 1 here, right? Okay, let's go ahead. So now we are at this, I is at 2. So we quickly check one condition, which is is 6 less than equal to 4, right? That's the condition, which is that like this is the condition given by the question, but what we'll be checking is that something like prices of I, prices of I is less than or equal to prices of stack dot top, right? So which means that prices of I, which is 6, is less than equal to something which is at the top of the stack, which is 4, right? So at index 1, what is the value? 4. So 4 is greater than equal to 6. So yeah, right now that condition is not being satisfied. So what we'll do is we'll continue. So we'll continue to the next value, which is 2. So I comes here, and actually we'll push this value as well in the stack. So 2 is also pushed. Now like what we have is at 3 index, we have 2. So at 2, we'll check prices of I, which is prices of I. What is the price of I? Which is 2, right? So is 2 less than equal to the top of the stack, which is 6, right? So yeah, it is. So what we'll do is we'll pop this out and decrease the discount for this. So this becomes 4, right? 6 minus 2, right? So that's how this one is gone now. Next, we'll keep on, because I said it's a while loop, so we'll keep on doing it. So again, we'll check the while the stack is empty, we'll check the next value, which is index 1. So index 1 is 4, and index 1 is 4. So 4 is definitely smaller than 2, right? So we'll decrease it and make it 4 minus 2 is 2, right? And we'll go ahead now because the stack is empty now. So we'll go ahead and now we'll push the value of index of 3, right? So now we have 3 here. And now we'll go to the next step, which is here. And here we have 3, right? So we'll quickly check, is 3 uh, smaller than equal to 2? No, right? Because prices of I is less than equal to the stack dot top. No, that's not how it is. So we'll just go ahead and just pop this, basically put the other element as well in the stack, which is 4. And yeah, that's all. That's what we'll do. Because yeah, the array is done. So now we'll get the final answer as 4, 2, and 4, 2, 3. And that is the final answer here. Let's get to the coding part. So what I'll do is I'll maintain a result array here first, which will be basically the replica of prices. And then I'll also maintain a stack, which will store uh, the the values which are in the indexes of the prices of I. And then I'll the iterate through the prices of I. And yeah, here we'll have that condition which I was talking about, which is that we'll check, is stack dot empty? Uh, if it's not, then we'll be checking prices of I, is it less than or equal to prices of stack dot top, right? So like yeah, we'll be checking, is the value, like for example this 2, is 2 less than equal to this value of 6, right, which is at the top of the stack. So once that's done, what we'll do is next step is we'll get the result of stack dot top, and we'll subtract, because that's what we are going to do, which is discounting the prices of I value, right? And once that's done, we'll get it out of the stack. Yeah. And the next step is we'll also keep on pushing the I value index inside the stack. Yeah, I guess that's all. Then we'll return the result. So yeah, that's the idea. What we're going to do is we'll maintain a vector result array and put everything of prices inside it. We'll maintain a stack and iterate through the prices array, and we'll have a stack. We'll have to check the stack dot empty. Is it empty? And this condition, which is specified here, and then we'll subtract and put the discount and push the value inside the stack and return the result. So let's run this code. Yeah. Awesome. So that works. Yeah, that was it. I hope you like it. Thank you.